quadratic equation, and it's more like it's related to this. That's why we will be doing some of it. You already know it. It's more like a redundancy in terms of the chapter which you have in NCRT. So things will be repeating here, but it is actually more specifically will be working with only quadratic equation here. So you remember we had a quadratic equation ax square plus bx plus c equals to 0. This is the general quadratic equation, and you as well figured that alpha and beta be the roots. Then alpha plus beta would be minus b by a, and then alpha into beta would be c by a. This is something which we had learned. Now, what we are trying to do here is in this chapter is that we are trying to find the roots or zeros of the quadratic equation. So one way you had learned is to do the factorization and then find the solution. So the first method to find the solution basically, rather what we are trying to do, we are trying to find the solution of the quadratic equation is what we will be trying to learn here. So there will be three methods which we will be learning. One is what we are calling factorization method, which you have learnt it in the polynomial chapter as well. The second one is called completing the square method. The third one is called basically using the formula. So we will derive the formula and use it as well. But uh, we'll have to learn this quadratic. It will not leave you even when you come to 11th standard and 12th as well. So this is again gonna be a chapter in itself when you are trying to learn this, right? So we will learn something as well, that a solution of this quadratic equation is what we are calling zeros or roots, and we will also try to learn something about this nature of roots as well. How these roots would be, nature of roots as well. So we will learn that they will be sometimes equal, there will be sometimes unequal, and then sometimes they will not be even real. There will be unreal roots as well, or imaginary roots. Imaginary roots will not be learning in this class, but that will make an appearance in 11th standard again. So this is gonna be an important chapter for your future references as well. So that's the reason we will be spending a lot more time on this. Let's do it again. uh, we look at this, okay, so okay, we look at this number, the constant term, and then what we do, we try to factorize it like this. So this factorization is 2 and then 5. So I've got this 2 into 5. Now 2 into 5 is a factor, so I can write this as x square minus 2x minus 5x plus 10 equals to 0. All right, and this will be actually x common, then this will be x minus 2 minus 5 common, x minus 2 equals to 0. And then this will be x minus 5 into x minus 2 equals to 0, and x equals to 2 and 5. Okay, so what has happened here is that if you look at this, we had this identity x plus a into x plus b, and this identity used to be equal to x square plus a plus b into x plus ab. Now, whenever we are trying to factorize it, we are trying to get back to this level. Okay, we are trying to get back to this from here, and you compare this. This is x square minus 7x plus 10. When you compare this, what it means is that AB is equal to 10 and A plus B equals to minus 7 actually. So you have to have some numbers over here as product of two numbers, so that the sum of these two numbers would be equal to minus 7 is what we have to get to. And when we looked at the factor, we got two numbers as minus 2 and minus 5. Okay, when you multiply these two numbers, you will get 10. When you sum these two numbers up, you will get minus 7. Okay, so you start with this always. You start with a constant term, try to factorize it into two numbers. And then once you get these two numbers, either sum or subtraction, somehow you have to get this number which is in the middle. That is how we do the factorization. Okay, really simple visual. Minus x minus 4. Now I have to look at this constant term which is 4, and trying to factorize this will become 2 into 2. So 4. So if I'm comparing this, what is happening here? My AB is actually minus 4. My A plus B is actually minus 1. So I have got factors like 2 into 2, which is 1. I've got one factor is 2 into 2. But there is another factor which is also hidden in plain sight, which is also got. Uh, hmm. So what is gone wrong here is, see, one second, there is something which I have to again correct here. Where is it? So when I was saying this, look at constant term only when you have this as empty, right? But when you have something over here, you have to actually look at both the terms together and multiply actually. So you have to have 3 into minus 4. This is actually minus 12. And now try to get this. So minus 12 is already being factorized into 3 into minus 4. So you can write this as 3x square plus 3x minus 4x minus 4. So this part is actually already becoming minus x. This is the remaining 3x square. This is minus 4. Now you can actually simplify by taking this as common. Uh, this is going to be equal to x plus 1. This is going to be equal to x plus 1. So this will become 3x minus 4 and this will become x plus 1. And then while equating to 0, you will get the other one. But let's do some easy ones on the 10. Square minus 3x minus 10. Now, if I am looking at this one, now I have to find the roots of this equation. So my constant term is actually minus 10. Here it is 1 already. So if I multiply it by 1 also, it will not matter. So 1 into minus 10 was what I had. So now minus 10 I have to factorize minus 10 or other 10 first. So I get 2 and 5 here, uh, which is more of a factor which if I sum I'll be able to get this. So I have to intelligently do it so that one thing I have to put as minus, another one I have to put as plus. Then what will happen here is that the sum of this will become minus 3x and then it will be easier to solve. So I can write it as x square minus 5x plus 2x minus 10 equals to 0. Now this will become x square x common x minus 5 plus 2 common x minus 5 equals to 0, or x minus 2 into x minus 5 equals to 0, which is gonna be x plus 2. Okay, so let me just take another one which will be little complicated. For example, this one. So what you need to factorize is 5 root 2 into root 2, which is nothing but 5 into 2, which is nothing but 10. So you have to factorize 10. Just writing whatever you're telling me. So root
Okay.
5 plus 2x plus 5x plus 5 root 2. One second. So you took x common, so this will be root 2 plus 5, root 2 x plus 5.
Hmm.
Then
Hmm.
and then you took uh, okay. Okay. Now one way to do it is to do the factorization and do this. What we are learning is that completing the square method. What we are learning here is that completing the square method. So in this case, what we look at here is we look at first two terms actually generally, and what we'll try to make it as more like a square plus 2ab plus b square. So now if I'm looking at x square plus 6x, this is x square, and then 6x I will try to break it into 2ab, which is 2 into this a is x already, and then b is gonna be 3, because then it is going to become 6x. So now if this is going to be 2ab, so I have to have a b square also. So what is my 2ab? This is 2 into a into b. This is b. So my b square would be 3 square. Now since I have added this term, I have to also subtract it. So I will subtract 3 square as well. And then I was left with 5. So I will have 5 also. Now this thing has become x plus 3 whole square. When I'm looking at this, this has become minus 9. This has become plus 5. And now my x plus 3 whole square has become 4. Because this minus 9 plus 5 is minus 4. I sent it on the other side, this becomes 4. Now if I'm taking x plus 3, so this will be a square root of 4, and which will be nothing but plus minus 2. When I take x plus 3 equals 2 plus 2, then there will be one solution. When you take x plus 3 is equals to minus 2, then there will be another solution. So this is x is going to be 2 minus 3 is going to be minus 1, and this is going to be x equals to minus 5. Okay, so I have got roots as x equals to minus 1 minus 5. When I would have used the factorization method, I would have still got the same thing. Why? Because x square plus 6x plus 5 is 5. When I factorize, I will get only 5 into 1. So what I'll do is I'll write 1 x square plus x plus 5x plus 5 equals to 0. And this will be x plus 1 plus 5 x plus 1 equals to 0. And this will become x plus 5 into x plus 1 equals to 0. And x equals to minus 5 and minus 1. So here completing the square is what we are trying to do is we are trying to make this as a perfect square, and whatever be the number we will send it on the other side and then take a square root, take plus and minus. Once I'll take the plus symbol and then use it to evaluate the value of x, and then I'll use minus symbol and then evaluate the value of x. So this is another method of solving this quadratic equation. We will take another example and see if we are able to do it again. So let's look at this itself. X square minus 5x plus 2. So once we will factorize, it will be easy. But since we are just trying to learn the completing the square, so in such case, when you have this right, what you try to do is first you divide it with whatever be the coefficient of x square. So we will have x square minus 5 by 3x plus 2 by 3, and this will go to the other side 0 by 3, so it will become 0 itself. Now I'm looking at this and I want to make this x square minus 2ab because there is a symbol minus here. So when I'm doing this, I will have x square minus 2 times x is one thing, but I have to get 5 by 3 here somehow. So what I'll have to do is 5 by 3, so I will write, but I'll also have to write into 2 because I want to cancel this 2 out, then only I will be having this. So now this part which is there, which is 5 by 6 is my b, so I have to write 5 by 6 whole square because then it will become b square. And since I have added my 5 by 6, so I have to also subtract it, and then also I have got 2 by 3 equals to 0. Now what has happened here is that this has become x minus 5 by 6 whole square. This in these three terms, this and this together, because this is a square minus 2ab plus b square. This has become x minus 5 by 6 whole square. Then this has become 25 upon 36 plus 2 by 3 equals to 0. Or you can just write x minus 5 by 6 whole square equals to 25 by 36 minus 2 by 3, or which is nothing but 36 is this. Then this will become 25 and this will become 24. So this will become 1 upon 36. Now x minus 5 by 6 will be equal to square root of 1 by 36, which will be nothing but plus minus 1 by 6. So I'll take one time positive which will be 1 by 6, and take another time negative, which will be minus 1 by 6. So here it will become x equals to 5 by 6 plus 1 by 6, which will be 1, basically 6 by 6. It will be equal to 1. The other one will become 5 by 6 minus 1 by 6, which will be 4 by 6, which will be 2 by 3. So my two roots would be x equals to 1 comma 2 by 3. I could have easily factorized it also and got the answer, but this is the method which we are learning. At times it will become uh, easier to do as well. Here it was not. While you could have just factorized it, it would have been easier. For example, if it had been just 3x square minus 5x plus 2, you could have written it as 3x square minus 3x minus 2x plus 2 equals to 0, and this would have just become 3x and x minus 1. This would have become x minus 1, and then this would have become 3x minus 2 and x minus 1 equals to 0. So x equals to 2 by 3 and 1. So it could have been easier doing a factorization, but here we are just trying to learn a different method which is called completing the square. What we try to do here is that we make these first two terms in a perfect square by adding a constant term. And what constant term I have to add is, to figure that out, we write this is in the form of 2ab to get to the same number, and whatever be the b, we try to square that and add and then subtract it and then proceed further.